Okay, so here's the last little question. So this is, the scenario is this is not real, so you have to do all your homework, sorry. But the scenario is, I'm planning to give you 7 problems for homework. As an alternative, you can agree to play the Lucky Day game. Here's how, okay, so you know how the Lucky Day game works, right? I think of a day in my head, I call in a student, they have to randomly pick a day. If we have a match, then in this case you would only have 1 homework problem, okay? If that student doesn't get it, then I pick a new day in my head, another student gets to guess. If they guess correctly, then we'd have 2 problems. So however many students it takes to get a match with me, that's how many homework problems you would have. So we want to figure out, first of all, if this is binomial or geometric. So since we're going until a student gets a correct match, it's going to be geometric. You still should go through the bits instead of the bins. So success is we get a match in the day that we're thinking of. A failure is the student guessed wrong. Each guess is independent of every other guess. We're doing trials until success, and each time I'm picking a new day in my head, so there's going to be the same probability of success each time. So anytime, let's let that helicopter pass. Sorry about that. Okay, so anytime you're doing a geometric probability like this, you are always going to have with replacement. Otherwise, it wouldn't be the same probability of success. It wouldn't be independent. So anytime you're doing this, if it's a geometric distribution, the process has to be done with replacement so that the probability of success stays the same. Okay, part B says, find the probability that the class will receive exactly 7 homework problems. So we're doing y equals 7. So it's with your calculator. Okay, I would practice doing this in your calculator to make sure you got it. So it's PDF because it's equal to, my probability of success is 1 over 7. And then the x value is 7. So we're saying on the 7th time you get success. And so there's about a 5.7% chance that you guys would have exactly 7 homework problems. The probability that you would have less than 7 homework problems. So remember, you have to convert this into a less than or equal to. So the probability that y is less than 7 is the same thing as the probability of y is less than or equal to 6. So you do CDF for that, and so you got about a 60% chance that you would end up with less than 7 homework problems. So kind of, I need to switch this up for next year. A better example would be of just however many guesses it takes you, that's how much homework you have to do, not that I'm planning on giving you 7. Because here you got a 60% chance of less than 7, about a 5-6% chance of exactly 7. But what does that mean? It means there's like the 66% chance of 7 or less than that. So there's like a 34% chance that you would have greater than 7 questions if I just said, hey, however many number of guesses it takes you, that's how many questions you're going to have. So I want to change that a little bit. Anyway, so that's the end of the section, and hopefully that will help you when you're doing your homework, and I will see you guys